Okay, good morning, all, and welcome back to the session. So, friends, in previous session we were discussing about multiple query, and what we have seen with respect to the multiple query. Uh, so, say if we are having one query, and what we are going to do, we are going to create multiple query on top of that, and then based upon those particular queries, we are going to perform the vector search in the vector DB, and then we will be retrieving certain documents, and then we will be going to merge these particular document, and we will be getting the final outcome. Okay, so we have seen two approaches with respect to that, and this is the approach like where we are going to merge. So over here, what we are doing, we are generating the four queries on top of a query. So we are passing the question, and we have instructed large language model to generate the four queries. That is perfectly fine. Okay, and then we created a query chain that is going to take this multi-query prompt, and we will pass it to the large language model, and we are you can say passing it to string output parser, which is going to visualize it in a better way. So that is perfectly fine. Now we are having the for query. This is the question, and now what we can do, we can these are the four queries. Like post execution, we are able to get these particular four queries based upon this particular question. Now what we need to do, we need to retrieve the documents based upon these particular four queries. So what I have done, I have defined a retriever. Okay, and retriever is defined over here. So first, like, I'm reading the document, then splitting the document, then embedding, and then retrieving those particular documents from the vector store. So the documents, the retriever is defined over here. So what I will do, I will iterate with the queries what I'm having, and I will retrieve the documents. So this is done over here. So I'm going to pick a particular query, and I'm going to retrieve the documents with respect to that. So it will retrieve four documents, and I have defined all doc, a string over a list over here, and it is going to club all of these particular documents inside this. That is perfectly fine. Now these all documents will be acting as a context for me, and I have initialized it as a context. Now I will define another prompt, and in that particular prompt I especially mention that you need to answer the question and utilize this particular context. So context is this one, and question is whatever we have asked. So then I will create a chain, and this will be, say, final chain. It will be using the final prompt. It will be passed to the LLM and string output parser. And once I'm going to take the answer, I will invoke this particular chain, and then I will be able to get the answer. So this particular approach is fine, but there is an issue. Okay, probably I should taught this particular approach in the first go, and then the later approach where we were facing certain challenges. So what are those challenges? I will explain those particular things as well. So we are able to get the outcome, but the issue with this particular approach is, say, if we are having duplicate documents, we have seen like the queries which these particular queries which are generated, these are generated based upon the initial query. Okay, so these are more or less similar, but similar to the initial one, and somehow a modified version of the initial query. Okay, so the outcome that we will be getting, probably we will be having one or two documents similar in each and every query. Okay, so what I need to do, I just need to remove that particular duplicacy as well. So yesterday we have discussed about this particular function. Just have a look over here. Okay, we were discussing about this particular function, modify doc structure, and like in order to explain this particular function in a better way, I'm having this particular stuff. Huh? So say we are having document a list of list. Huh? Yesterday, so guys, what is being happening over here? We are using the different large language model, huh? And the outcome what we are getting from the different large language model, it is onto the different you can say formats, huh? So previously once I have done the practice, so I was getting the outcome in list of list format, huh? Okay, I was getting the outcome in list of list format. It was looking like this, huh? So document is there, say if documents are A B C D, and this is same what I was trying to explain. Okay, so if we are getting the documents in this particular way, what we need to do? First, we need to flatten these particular documents. Flatten, what is the meaning of flatten? It means I just need to create a list from this list of list. So over here, this particular line of code, flatten doc, that is going to take dump, which is you can say inbuilt function from the LangChain only, and I'm going to iterate with this particular list of list, and I'm going to first pass it like for document in sub list. So this is you can say list initially, and uh, in order to you can say flatten this, and I just like say if I'm having list of lists, so I'm going to flatten it in a list, single list basically. Okay, so over here once I'm having these particular documents, so list of list is you can say converted over here. Just have a look, these particular documents are in a list, these, this is the another list, and this is the another list, so three lists are there, it has been converted into the single list basically. Okay, so flatten is working in this particular way, and then another line, what it was doing, it was converting these particular documents into the unique one. So say BB was converted to single B, C was there, D was there, I think it was A was repeating, so it is you can say unique, A is captured, D was not repeating, so D, A, B, C. So we are having four documents over here. We are having six documents. So same I was trying to explain uh, over here that like we have written this particular function in order to flatten the list of list to a single list, and then the list of list what I was having, it can have the duplicate documents, and these particular documents are converted to unique one. So list of list, the flattened docs, then I passed it to, I have taken the set from it, and then I have converted it into the list. I have converted that set into the list. So I'm having the unique document, and now I will pass these particular documents to the large language model in order to get the answer. So same I have done over here. Okay, so I have like I was having the documents, I passed these particular documents from this particular function. Okay, modify doc structure is a function which is going to take all of the documents, and I will be able to get the unique and unique documents in terms of a list, and then that will be acting as a context for me, and I will pass this particular context in order to draft the answer, in order to create the answer. Now, there might be a question in your mind like, once if we are having the duplicate data, if we are having duplicate data, and we know the large language model is smart enough to provide the outcome based upon that. Okay, might be there is a question in your mind that if we are passing the duplicate data, duplicate documents to the large language model, what is the issue on top of that? Can you tell me what is the issue if I'm passing the duplicate content, duplicate data to the large language model? What will be the issue in that approach if I'm passing the duplicate data?
The unnecessary token will be taken because you are reading same thing again and again.
Correct. Okay. So it is going to consume the tokens. Okay, and tokens are similar to tokens are uh, equivalent to, you can say, price or cost. Correct. If I'm consuming more token, I need to pay more. And you can see the graph over here. Okay. So if I'm using more tokens, okay, then I need to pay more. Correct. So we are having say 96 requests and it is going to consume some amount of tokens. So we need to pay more. Second one, the context size will be more and it will be going to add extra latency in order to get the outcome, because the large language model need to analyze, it will be going through with the all of the docs, and it will be going to frame the answer based upon that. Another issue, once you are going to pass, uh, we have faced this particular challenge. Let me talk with respect to my experience. So we were having a scenario that will uh, be useful for you once you will be working onto the actual data set or in your probably upcoming organization. So what we are doing, we are having certain permanent documents, permanent docs. Okay, and we are having certain temporary docs, temporary docs. Okay, permanent docs means those are ingested with the pipeline, or those are inside the storage only. Okay, say you can take it in this particular way. I'm a user, okay, and user is having a particular chatbot, and there are two options. Okay, so two options are there. First one, like user will be able to ask, let me mention, user will be able to ask the questions uh, based upon the documents which are there in vector store. Okay, so user has not uploaded these particular documents. uh, it is already there. Say I'm a user, and I am going to use a particular chatbot, and I just came onto the portal and I type my query and I was able to get the outcome. This is the first approach. This is the normal approach. Over here, say if you are onto the chat GPT, okay, and you just ask like what is the current time, or what is lang chain, say. Okay, what is lang chain? So lang chain, so lang chain, it has given me the information. Okay, so this is the first approach, means it is providing the outcome based upon its knowledge, based upon the documents or whatever is available in its permanent storage. So these are nothing but the permanent docs. Now onto this particular chatbot, I'm having the option to upload the docs as well. So I can upload a particular document over here, and I can say, this is a LangChain document. I'm uploading it, and I can ask what is, provide the answer based upon uploaded document. Okay, so now it will read this particular document and it will provide, so it is going to provide me the answer, and it is sharing the source information LangChain doc. Okay, and LangChain doc. Now just have a look. The information, the source information is LangChain document. Correct, guys? Are you with me? Are you with me?
Yes, correct.
Yes, yes, okay.
Temporary doc.
Correct.
Okay, so temporary doc. It means user uploaded this particular document. Na? Okay. Now there is a combination. So user either can ask uh, from permanent combination of queries. User can ask from number one permanent doc, okay, which is already there inside the storage, which the user has not uploaded. Second one, he can ask from the temporary docs that we have asked, okay. And third approach, what it will be, temporary plus permanent. Okay, we are having three approaches only. Once we are having certain documents, so we can ask to the chatbots in these three formats. Correct? Fine so far? Is it fine with everyone?
Yes.
Okay. Now issue will come over here. If you are asking with the permanent storage, okay, those are inside the permanent, you can say, vector database, or those are uh, given in order to train the large language model. That will work perfectly. Now, if you have uploaded certain document and you are asking, especially from the temporary documents, then that will also work perfectly. But issue will come once you are having the temporary plus permanent selection. What will be the issue if there are the same documents? If there are same documents from the temporary plus storage, and say the name is same, but the content is a little bit different. The content is a little bit different. You can say uh, that is the newer version of the permanent one, or what I can say employee data, employee employee doc is one document, and then I have uploaded the employee doc. Okay, so it is available in temporary as well, it is available in permanent as well. Now large language model is not smart enough in order to provide the outcome from which location. Okay, if the file name is same, and say probably the temporary one what you have uploaded, it is having the newer version of it. Say the employee docs you have generated it in say October. Now you have generated the same file in say March. So this particular March one file is having the updated information. This is say October data. Okay, this is available in the permanent storage, and it is user it is what the user has uploaded. Now once like the user has selected temporary plus permanent, it is not smart enough like which one to pick. Okay, and probably say the user uh, once the user is going to ask the question, say if it has picked this particular october dot employee.txt, the October 1 file, so the outcome that we will be getting, that will not be fully correct. Are you with me? Are you with me? Guys, are you able to
Yes, yes.
understand? All
Yes,
of
yes.
you?
Yeah.
Yes.
Okay, so what will be the solution for this? Huh? Anybody tell me? You know the problem. What can be the solution over here? Huh? What can be the solution? What we need to do? How we need to instruct large language model? Can anybody? You can try. There is nothing wrong or right. You can try at least. Hmm? Javed, Lakshmi, Nikhil, Manish, Raj, Vikas. Can you try? Like, what will be the solution? It's very simple, and if you can try, then you will be able to provide the answer. Huh?
Actually, we need to remove the duplicacy.
That is that can be the solution. Okay, that can be the solution, but it will be tough to identify like how many files are duplicate in the permanent one, and we the user, say I am the user and I came onto the chat board and I'm having one document. I don't have the information, and say in the organization there are thousands of employees, so they don't know like if this particular file already available inside the permanent storage or not.
We can rename it with underscore something.
That you can rename, but what will happen once it is not going to search with the file name, to be very frank, it will perform the search with respect to the content. Okay, the query asked and it will search for the relative documents. Okay, so based upon that, it will find the information from both of these particular files. But that is a good try. Removing the document, that can be the solution. Changing the file name, yes, if like the LLM is going to consider the file name, but LLM is working onto the content. We know it very well. What else? What else we can do?
Is there
We can
possibility we can
yeah.
merge these documents?
Merging,
We can we can
uh, the user who is onto the portal. Just please go on mute, Javed. Uh-huh. So the user who is onto the portal, he will not be able to do this particular thing. Okay, I am the say I'm having the thousands of user, and uh, he will not be able to do this particular thing. Yes, it can share it to the developers, and the developers can check and merge and then have the updated one. Okay, so remove both and then insert the updated one. That can be done, but that will be the time taking process. What can be done? What else we can do?
we
Try.
can instruct with help of prompt.
Yes, that's what I want to hear. Okay, so you can provide instructions in the prompt only, and you can say, hey, if you are getting the same response from temporary and permanent storage, you just need to prefer the permanent or temporary. So over here, say the user is uploading the updated information. I will instruct large language model, pick up the permanent temporary storage first and then consider the permanent one onto the second priority. We can modify the prompt in this particular way, and you can maintain the versions as well. So align the large language model, consider the permanent storage onto the list priority and make it the version 2 or 3, whatever. Okay, so we can correct it, we can modify the response, we can align the large language model to consider which data store at the first preference, and we can write the code in order to maintain the versions as well, huh? Correct. So all of you, whatever you have shared, that can be the solution. Okay, that can be the solution, but whatever, which one we need to pick, that you need to decide, huh? Which one is a quick fix, that we need to decide. Correct. And we face this particular issue, huh? In our prompt chatbot, we face this particular issue. We are having these particular things. Okay, so any query with respect to this one? Multiple query, the RAG optimization technique, huh? Anything that you want to understand? Is it fine now? Guys, is it fine?
Yes,
Yes.
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 Yes,
Perfect,
sir.
huh? So what we can do in today's session, we can discuss about the RAG fusion. So these are the imports, what I can have, and this is the API, and I will proceed with these particular things. I will read a document, and once we are talking about the RAG fusion, so RAG fusion is like user is going to query, then based upon this, like we are going to generate the four queries. We will be retrieving the documents. So up to so far, this is similar to the multiple query. Then docs for each query, yeah. So whatever docs for each query, that is perfectly fine. We will be retrieving the documents, huh? Then whatever is retrieved, we will be going to pass it with the reciprocal rank function or fusion, basically reciprocal rank fusion. So what we are going to do over here, we are going to provide a rank to the documents whatever we have generated, huh? And based upon the rank, the large language model is going to pick the the documents which are having the good rank, and then those particular documents will be clubbed together in order to provide the answer. Correct. Now let's see how we are going to implement it, huh? Mhm. So we have loaded the documents, that is perfectly fine. Now we will proceed for splitting, embedding, and moving these particular documents inside the vector store. Okay, we have defined retriever, and it is going to retrieve the documents from the vector store. That is perfectly fine. Now what we will do, okay, so at this moment what we will do, we will define a RBF, huh? Okay, reciprocal rank fusion. Okay, this is a function what we are going to define, and what it will do. So let me mention the def reciprocal rank fusion. I will have say result and k equal to 60, huh? Just park this particular k equal to 60 in your mind. We will be having the detailed discussion on top of this, and I can have score. Then for dogs in result, for dogs in result, for rank comma dog in, and I will pass these particular dogs over here. Key equal to dog dot score equal to so I'm going to define a reciprocal rank fusion function. I will explain these particular things. Okay. Uh, or you can say this is a straightforward code. You can do the copy and paste, but like I will explain these particular things. So rank dogs, shorted score dot items, and this is the function that we have. And now I can have these particular things. I can utilize these particular things, whatever we have seen in our previous session. So queries. So I have defined a retriever. I need to generate the four questions. So these particular four questions will be going to utilize, uh, will be going to fetch the documents from the retriever, and then I will be utilizing this particular reciprocal rank fusion function in order to rank these particular documents. So I will pass the documents, and I will be getting the ranked documents basically. Okay, so I can print the queries. These are the queries. So I can have, let me do the execution. Query chain is not defined. Query chain will come from here. I will define this multi-query prompt and define the query chain as well. So I'm going to utilize the code whatever we have written in our yesterday's session. LLM is not defined, so I will define the LLM as well. LLM is defined, multi-query prompt is defined, and query chain is defined. Now reciprocal rank fusion, and then what else? Question is not defined. Now let me define the question as well. Okay, this is the question. Split. It is going to generate the four documents, four questions, and these particular four questions will generate the four documents. Retrieve documents. It will generate four documents. That is perfectly fine. And page dot content, I can say display only say 200. So it will, or say top 50. And let me print the documents as well. So it is going to print the documents, print query, say. So query 1, this is the query 1, and based upon this particular query we are having 1 2 3 4 documents. Query best practices, query how to optimize. Okay, so we are taking just say first 50 only. Okay, and this is with respect to the query 1. First 50 you can say tokens. This is with respect to query 1, this is with respect to query 2, and this is with respect to query 3, and this is with respect to query 4. Okay, so we are having the outcome with respect to all of these particular queries. Now what I will do, I will have say focused docs, and I will do what. So all docs, I will pass these all docs from reciprocal rank fusion function. String object has no attribute based content. Where is the no? So I just want to print none. So we have not appended. We just need to insert all docs. That is perfectly fine for queue inquiries. Docs equal to retriever invoke queue. All docs dot append docs. That is perfectly fine. Let me remove this particular print or print. That is fine. Let me keep it. For the docs print doc dot page content and let me remove this. That is perfectly fine. Score. Okay, it is with respect to hmm, my mistake. Print docs. Okay, so uh, what we will be able to see over here, I just need to copy. I will explain this and then we will discuss about the rank fusion function with what it has done now. So score. Just have a look over here. We are able to see the scores as well. Correct? Are you able to see? At each and every line, new line, we will be able to see the score. Score is not coming. So over here, friends, what we are able to see, we are getting the score with respect to the documents what we are having. We are having the score as well. It is not mentioned in a correct way, but like the score is there, which was previously not available. If we were referring the documents, so this particular score information was not available, and we have picked a score over here, and let me try to do let me try to change the document or this particular, you can say, loader, and then we will be able to validate it in a good way. Let me have LangChain 11, and let me change the file over here, and then you will be able to see. Let me do this. So what I will do, text loader, and I will paste it over here. Text loader dot load. So text loader and docs, what we can have this one. Rest will be the same. What I think. Let me try to do this. Hmm. Just have a look over here. So we are having the scores. Sorry, we need to. Probably it is printed one. Okay, so we are having the score information. Previously it was not available. We are having the score information. Okay, we are having the score information. Is it, guys? Is it fine? Previously it was not there.
Yes, yes.
Okay, so at this moment we are able to visualize it.
Able to visualize it. How the score is being calculated? What
I
is the
will come
criteria
on.
for that?
I will come on. I'm
Okay.
coming on that point.
I'm coming on that point.
So this is
So
based
this
upon
is
our.
based upon our.
Can you go on mute, Javed? This is based upon the RBF function what we have defined. Okay. Now, what exactly is being happening inside the RBF function that we need to learn now. Now, over here, with respect to the RBF function, so it is going to create the score for each and every document. It is going to like uh, score is already there. Okay, it is score is already there, but what this particular RBF function is going to do, it is going to calculate the rank on top of this. We have seen, once we are fetching the documents from the vector store, we have seen the score information as well. Are you able to recall? Have you seen the score information? Say yes or no.
Yes, yes.
We are having a function with the help of that we will be able to see the score as well. Similarity search by score. Is it?
Correct.
Yes, yes,
Correct.
yes.
Okay.
Yes, yes.
Yes, yes.
So score is already there, friends. So what we need to do, we need to calculate the rank. And now I will tell you like how this particular rank is being calculated. So with the function that we have written, I just want to explain like what is being happening in this particular function. Okay. So what uh, we are having what I can say, all docs, this is looking like this, say doc1, doc2, doc3, doc3, then doc2, doc3, or let me mention it in this particular doc A, B, and doc C. Then doc B, D, and doc A. Okay, that can be the answer to the second query. I'm going to explain with the help of three. Okay, doc A, doc E, and doc B. Okay, this can be the data to all doc, whatever we are having. So we, in this previous example as well, we have calculated all doc, we have calculated all doc over here, okay. Inside the all document we can have the data in this particular way, correct? We can have data in this particular way that we have seen, correct? With the help of this particular example as well, we have seen that the documents can be in this particular way. We have flatten and all, correct? So inside the old doc, say suppose we are having this particular data, and we have defined the score, and the score is defined in this particular way. Say score is what? Uh, Score is defined as blank in our function. Now, what we can say score equal to this. Say this is a dictionary, so we will be having say tn value pair. Say doc1 is having say 0.232, doc A basically, doc B is having doc A, doc B 0.12123 say 1, doc C it will be say 001, doc D it will be 0. I'm just typing certain numbers over here, and doc E. Okay, so our main motto is to calculate the score in this particular way. These are the documents, these are the input, and our main motto is to have the score in this particular way, so that I will be able to provide the documents which are having the good score, and the large language model will be able to the pick those particular documents, correct? Is it fine? Up to so far, is it fine?
Correct, sir. So it will work based on repetition only, na sir? The ranking will be prepared based on repetition. Correct, sir?
Repetition, uh, we can
Whatever
give.
document having the highest repetition, it will be provide the highest priority. Correct, sir? Na?
Yes, that can be given a good, like that can have the good score as well, okay. If a question is searched, definitely it will be having the good score. If it is coming into two or three, you can say searches, two or three question searches, that means that question will have more similarity, and definitely the score of that particular document will be more at that moment, Okay.
Okay, sir.
Okay. So now, now what we will do, we will these are the score basically. Although like this is not the final, you can say, uh, requirement. Our requirement is to calculate the rank on top of this particular score, huh? So we will be having the documents saved, and we are going to capture the score, and we just need to do outcome will be like this, huh? So it will be say doc A, say rank 1, doc B, rank 2, okay, doc C, rank 3. Okay, so this is our expectation, huh? Now what we will do, so what we will do, we will calculate the score. Okay, so over here, what we will do, we will calculate the basically, uh, 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 let me then copy this particular piece of code, huh? Okay, so over here we are taking all the documents, huh? And k equal to, we will discuss about k equal to 60, no need to worry. We have defined a dictionary that will be going to take that is going to like have the score of each and every document, huh? Now we are iterating with the for loop, and we are selecting each and every document, okay, from this particular result. Our result is having all the documents, which have been fetched by the four questions, now what I will do, say I have selected one document, then what I will do, I will select a rank and doc from the document, okay. I will select a rank, and over here rank will be the position of the document, okay. Rank will be the position of document, and I will say key equal to doc dot page content. So doc dot page content will be the key, and then score of this particular key, what it will be, I'm going to calculate it with the help of this particular, you can say, function, this particular uh, formula. Okay, so what I will have, say over here, rank equal to document position, and k equal to, we have used k over here, okay, k equal to smoothing constant, it is coming from here, smoothing constant, and usually we keep it 60, it's 60, okay. So this is with respect to what, the k, okay. So 1 divided by the position of the document, say it is 1 plus 60, okay. So it will be, say 1 divided by 1 plus 60, okay, 1 plus 60. So I will get the outcome something like, say 0.000023, it might be, so we will got the outcome in this particular way. Now we will be getting the rank for all of the documents. We will be getting the rank for all of the documents. Now, what will happen? Why we are keeping this particular k, that is smoothing constant, equal to 60? Why we are keeping this particular value to 60? So there is certain, you can say, guideline. Just a minute, I just need to check. Okay, so now we are keeping k equal to 60. Yeah, that is smoothing constant. Now what will happen if we are keeping the small value of k? Yeah? So say for position 1, let me try to have the calculator. So 1 plus 1, sorry, 1 divided by 1 plus, sorry, 1 and divide by, what is being happening, 1 divided by 1 plus 60. Over here it will not be. Let me have Excel. Bracket and all are not working properly. I know what I need to explain. I just need to check the correct. So 1, 2, 3, 4. Okay, these are the dog positions. Now I am going to calculate the score. So 1 divided by 1 plus 60. So we are having this particular value. Okay, and in this particular way, like, we will be getting these particular values. So uh, the dog position 1, which is on to the first position, say it is having this particular score, it is having this particular score, it is having this particular score, keeping k equal to 60. Okay, now if I'm going to take k equal to, say, smaller value, okay, say 2 or say 1, keep it, say 1. Now what will happen, the difference between these particular score will be more. Okay, and so position, let me take position 0 as well. Okay, it is not coming. F12, F12 is this one. F13, 1 plus 1. This is 2. Okay, so in this particular way, like, what we are having the huge difference. If we are based upon the document position, if we are trying to calculate certain score. Okay, so difference is huge. So in order to smoothen this particular difference, the k equal to 60 is the good value. Let me mention k equal to 100. If we are keeping it like more, if you're trying to keep it more, then the difference, just see the difference at this moment. Okay, it will be it will be more compared to this one. So it is decided in such a way, like researcher has done this particular research, and the smoothing factor what they have decided like k equal to 60. This is not with respect to the documents what we are going to fetch. It is the smoothing constant what we are, or a particular variable that we are going to keep in order to provide, in order to have the calculation of, you can say, score and all. Okay, so it is decided in that particular way. So k is pegged to 60, and we are using it as well. So it is decided in this particular way. So score is defined as a dictionary, then we are iterating from the documents what we are having. We capture each document and then find the rank from there, and then doc key equal to the page dot content. Okay, and we are going to calculate the score uh, on top of that. Now this particular score what we have captured, then what we are going to do, we are going to short these particular, you can say, documents. Okay, say we are having certain mechanism over here now, or certain score over here, then shorted is being applied on top of that score dot items. So whatever is there inside the score, we will be taking it, and key will be the initial value, and like we will be treating, say, with the score, and it will be, say, reverse direction, like top will be more score will be onto the top, and then we will be going to return these particular documents. Probably you are able to get this particular function, is it?
One doubt here.
Uh-huh.
What is there any difference in rank and score? Rank is based on similarity search only, right? So whosoever doc is having highest similarity, that will be ranked one.
Higher similarity, no, over here basically how we have given the rank, we are having 16 documents.
Okay.
Okay, we are having 16 documents, and what you need to do, you need to sort them based upon the score, right? But over here, if you are previously, we have fitted these particular all the documents. Okay, and we have fitted all the documents, and there is no, you can say, mechanism what is being happening to, let me try to explain with respect to.
Explain with respect to.
Okay,
So you mean to say the highest score is will be getting higher rank, right?
yes, yes, yes.
Yes. But we can pick with the help of score only. Now, why you're using rank then?
uh,
Ah,
you can
Just a
pick
thought
with,
in my mind.
you can pick with,
You can pick with score only.
uh, okay,
Ah, okay.
let me explain.
Let me explain.
So
So
just go on mute,
just
please.
go on.
Okay, so we used to fetch documents. Just try to think. We used to fetch docs. Okay, and over here we are taking, say, four documents, four documents, uh, or five documents basically. Correct. But in real scenarios, okay, we once we are going to search, okay, we are getting, say, if the data is used, we are getting, say, 200 docs which are having, which are matching with respect to the question. 200 docs are there. Now these 200 dogs are having certain score, and if I'm going to provide these 200 docs to the LLM, okay, it might be possible like certain documents are having good similarity score or certain documents are having less similarity score, but at this moment all 200s are given to the large language model, and what will be the issue? uh, Quality, quality of outcome will not be correct, if I provide all dogs. Okay. Second stuff, what I have done, I was having four questions, and based on four questions, that is say multiple query, multiple query. Now, multiple query, what it has done over here, say I had 50 plus 50 plus 50 plus 50. Okay, okay. So these particular questions are here, and say by removing the duplicacy, I'm having say 180, 180 questions. Okay, that I have given to LLM. At this moment, 180 questions are given to LLM. Okay, is it fine? Is it fine? Or
Yes, yes.
okay, let me refine it a little bit more. And 200 dogs are there in search, and I instructed that 100 need to be given to LLM. Okay, so out of 200 documents, which 100 I need to give? I don't have any mechanism over here. So these particular 100, it might be possible those 100 are given which are having the list, you can see similarity. 200 docs was there in search and 100 was given to the LLM, and I don't have the similarity score information here. Okay, so it might be possible less similarity score. First 100 will be can have the less similarity score as well. It might be possible say 100 out of 100, 10 or 20 to 30 documents were there which are having list score, but they were given, right? Now I used multiple query and it has given say 200, and once I you can say uh, remove the duplicacy, then I got 180. Then out of 180 I need to give say 100 questions to LLM, 100 to LLM, because I restricted say LLM will have 100 documents only. So out of 180, which 100 I need to give? At this moment there is no any you can say score or ranking related information, so it might be possible first 100 over here say 30 questions were there with less priority or less score, say less score. Okay, so these were given over here. What I can say, the issue is like a little bit resolved, and 20 questions were given with less priority, less score with less score. Now it's rag fusion. Okay, over here say I searched this say 180, remove duplicacy, 180 questions are there. Now I have done the ranking onto these 180 based upon score. Okay, ranking is done, and now the 100 which are having good score will be given to LLM. Correct? Are you able to see the difference?
No, but here ranking, while calculating the score, you are using rank, right?
Hmm.
And again, based on score, you are doing ranking. So from where the first rank came out? Can you come to the Excel?
Okay.
So this dog position, this is also ranking, right?
Correct.
Based on which you are calculating the score. And from score, you are again doing ranking.
Okay, so you can take it in this particular way. This particular rank, this is with respect to say first query. Okay, first query has given me this, second query, third query, and fourth query. So at this moment, the rank of, are you able to, like, you have taken it with respect to the single query only. At this moment, that is fine. But we are asking for questions. And then cumulative, we are doing the sorting.
Sir, I have one sir, doubt in mind, sir. Actually, when we were doing the practical on restrict the prompt and find out the source information,
Mm-hmm.
then we have seen like whatever similarity score is lower,
Hmm.
that is better.
Yes. So it depends upon the algorithm, whatever you are going to take. Huh? Okay. So if you can change this reverse, you can remove the reverse, then it will provide the outcome in ascending order. Huh? There is no, that is not the concern. But I just want to answer the question which is being asked. So say with respect to the first question, like I'm having the ranking of the document. Huh? Question one. Okay. Question one, and then question two. Okay. Question three, question four. I was having
So
four
within question one, you decided that you will retrieve four documents. So these
Yes,
are those four documents, right?
these are four
So
documents.
how you decide the position of those documents, that this will be first, this will be second, this will be third, this will be fourth. It will
Uh,
be random.
Ye- this is not random over here, like it can come in descending order, like the rank which is having the document which is having the good, you can say, score, that will come onto the top.
Similarity,
Okay.
good similarity, right?
Yes.
So B column, the dog position in the B column will be based on the similarity, and based on that similarity, we will going to calculate the score, and that score will be calculated for every query, and all document will be final rank will with the okay, I get
Okay, okay,
I get it.
so at that moment, say these two will be selected, these two will be
Mm,
selected, these two will be selected,
yes,
and
yes.
these two will be selected. Say if I'm going to take the top four questions only, yeah, right? Top four queries only, or top four outcomes only, yeah.
Mhm. Yeah, it's clear now. Thanks.
Okay, so we have given the score, and we are able to get the the best, you can say, documents which will be fitted to the large language model. Huh? Is it fine with everyone? Huh? So it's my mistake, like I have not quoted that this is with respect to the single query. Once you will be
So, sir,
having the, yes,
as per this methodology, whatever document is highest similarity, that will be rank one. Then after rank two, then after rank three. Correct, sir? So we need to select the similar document only as per the question asked.
similar document.
Hello?
So
Similar documents only as per question asked to create the like.
yes, yes. So the thing is that, like, we, these particular documents, whatever we are getting, all of these are the similar one, with respect to our base query. Okay, all of these are similar documents, to be very frank. But which one is having higher relevance, that we need to pick. Okay, so the query
Correct,
is
correct.
what we have asked. It has given says these 16 documents. Huh? These 16 documents. Out of these 16 documents, which one is having the highest, you can say, relevancy? So how I am going to check? So Based upon the document position, say I'm able to get that this is the correct one, and based upon that only I'm providing a score to that particular document. And I have provided the score to each and every document whatever I'm having. Okay, so the upper document, the document which is coming at the first position, that will be having the highest score, and it will be repeated with respect to each and every query. Correct? It will be repeated with respect to each and every query. Now I'm having the score with respect to each and every document. Now I can sort and I can pick the top n documents, and those particular document will be having the more relevancy. Over here, I have given this particular example. Say I need to select the 100. Okay, so these particular 50, 50, 50 were providing me the documents, and now out of these particular 50, which of all of these particular, say 200, which 100 I need to pick, so I can have the rank for all of those particular documents, and then I can uh, uh, you can say after sorting I can have first 100, and that will be more relevant, huh? Okay. Hope you all understand this particular thing, huh? Is it?
Yes, yes.
That is perfectly fine. Now, what you need to do, this is for you can say understanding perspective only. Now you are having this particular focus document. Okay. Uh, Outcome. What you can do, you can pass it from the the another prompt and large language model, and you will be able to get the outcome, and that will be more accurate compared to the previous one. Okay, is it fine with everyone?
Yes, yes.
Okay, so this particular part you can do, I will share this, and what you just need to do, you just need to take it as a context, uh, the outcome what we are able to get over here. Focus doc, it will be assigned as a context, and then this particular context we can pass from this particular prompt context equal to focus doc, and then we will be able to get the outcome, so you just need to repeat these particular three steps for context and set a prompt, and then the final chain and execute that particular chain, you will be able to get the answer, and try to match this particular outcome with the previous one whatever you got, and you can create the difference, you can see the difference, so that's it for this particular session. Let me stop the recording.